Imagine the unimaginable. A building, a symbol of stability and safety, suddenly transformed into a mountain of twisted steel and broken concrete. In the heart of this chaos, a clock starts ticking. This isn't a movie set. This is the reality for urban search and rescue teams, or USR. Today, we're going deep inside the incredible science, strategy, and sheer bravery involved in pulling life from the rubble. When a building collapses, the primary objective is to rescue the greatest number of people in the shortest amount of time, while minimizing risk to the rescuers themselves. To save lives, you first have to understand the physics of destruction. Buildings don't just randomly crumble. They fail in predictable patterns that rescuers are trained to read. A lean-to floor collapse, for example, happens when a floor fails on one side but stays attached to a wall, creating a large triangular pocket of safety. Then there's the pancake collapse, where floors stack on top of each other. It looks devastating, but furniture and debris can create smaller, life-sustaining voids between the layers. Identifying these survivable void spaces is the first critical step in finding someone alive. Long before a disaster strikes, structural engineers are the unsung heroes. They retrofit old buildings and push for stronger building codes, creating our first line of defense. But when the worst happens, they transform into first responders with blueprints. As a key part of a USR task force, their first job on a disaster scene is to assess the unstable rubble pile. They identify the risk of a secondary collapse, which could kill both rescuers and any survivors. They are the ones who decide where it's safe to enter and how to shore up unstable sections, making the entire operation possible. Once the scene is as stable as it can be, the hunt for survivors begins. This is a multi-layered, methodical process. First, they conduct a surface rescue for anyone easily visible or lightly trapped. Then, the high-tech search begins. You have the incredible canine teams, whose noses can detect human scent buried deep within the debris. Next comes the technical search. Rescuers use incredibly sensitive acoustic listening devices to hear the faintest tap or cry for help. They snake fiber optic cameras through tiny drilled holes, giving them eyes inside the voids. These cameras often have two-way communication, allowing rescuers to talk to and reassure someone who has been trapped, alone, in the dark. Locating a survivor is one thing. Getting them out is another monumental challenge. A typical federally organized USR task force is a self-sufficient unit of 70 specialists, search experts, doctors, logistics planners, and rescue technicians. They use an arsenal of tools, from massive cranes that carefully delayer the debris from the top down, to delicate hand tools for the painstaking work inside a confined space. Every move is calculated, because shifting the wrong piece of concrete could trigger a deadly collapse. The medical side of USAR is a field unto itself, called confined space medicine. Doctors and paramedics have to treat victims while they are still trapped. One of the biggest dangers is something called crush syndrome. When a person's limbs are compressed for a long time, muscle tissue breaks down and releases toxins into the trapped blood. The moment of rescue can actually be the most dangerous. When the pressure is released, those toxins flood the body, which can cause sudden kidney failure and cardiac arrest. To prevent this, medical teams administer IV fluids and specific drugs before the person is freed, a life-saving intervention performed in the most hazardous conditions imaginable. And of course, technology is pushing the boundaries of what's possible. Drones now provide an instant bird's-eye view of the disaster zone, mapping damage and identifying hazards. A new generation of robots is going where humans can't. Snake robots can slither through tiny openings, while new vine-like soft robots can actually grow into a debris pile, carrying cameras and sensors. AI is even being used to analyze social media posts and emergency calls to help pinpoint the location of people who managed to send out a digital cry for help. Urban search and rescue is a breathtaking fusion of structural engineering, advanced robotics, specialized medicine, and the unwavering courage of the teams on the ground. They operate against the clock, in constant danger, facing immense physical and mental tolls. It's a powerful testament to the human drive to engineer solutions in the face of total destruction, all to uphold their simple, profound creed, that others may live. As disasters become more frequent, the science of rescue will only become more vital.